So for this chapter we are gonna apply the solver as a trigger for the primitive motion, and this is the result we want to achieve. So let's go. So now I just would like to add a simple cache on the head, because I was realizing that this operation takes quite some time, so I just need to get a cache there before the animation. Okay, now I have done that, I will just copy paste the camera from what I've done before. I don't need to compute everything, so let's put it in manual, like this. This is a simple camera I've animated from the frame 1 to 150, as you can see, with two different keys. So let's go there and you can see those keys with the rotation as well. That's it. So I have something like this. Not you. Okay. So this is exactly what I need. Okay, let's go back to our solver. First of all, I have to say that I forgot to compute something, and I forgot to add an attribute delete as well, because I'm going to iterate over those points. So if you check it there, for example, there is the n', nuv, and the uv, and I don't need it actually. So let's delete everything with an attribute delete, like this. Perfect. So let's check just the position. This is what I wanted. Another thing that I forgot is to compute the age. So let's go there, and I would like when one point is going to be set to the value 1 from the CD, I would like to add 1 to the age. So let's do this. I'm going to create an attribute called custom age, let's say, cust age, and let's say if the color, the red color is different, not you, different than 0, then add plus equal 1 to the cust age. So let's rename this cust age attribute, okay, with the red color. That's good, and it should be alright. I need to check it, so let's get a visualize node. Okay, so I want the ramped attribute, let's say the cust age. I want the min max. I could actually set the 1 time at time inc, and I will get the result in second instead of frame, but I prefer to work with the frame, so it's more understandable for me. So let's get from the frame 1 to 100, sorry. I want a grayscale, and let's see the results. So from the back, yes, it works. So this is exactly what I wanted. Perfect. And it should be as well a bit faster, because I don't have any more to iterate and store inside the memory, the RAM, and all those data, the nuv, the n', and the uv. It should be good. And now let's cache it. So load cache 1 to 150, that's good. Update the version and render it. Okay, now I do have this. Let's check with the visualize, and it should be alright. And with the camera. Okay, perfect. So now what should we do? Let's say I would like to transfer the color, or maybe the cust age attribute, directly to these particles. Unfortunately, I have done those the solver over the static frame, so I cannot transfer with, like, let's say a PC open or a near point function over the deformed animation. So I'm just going to use this one, the static one, and use a function called near point. So let's import the solver points just there to make it. I need this actually. Import up and out like this. So now I would like to get an attribute called out near growth, let's say, and it's the near point petitum that I want from the second input and with the p as reference. So now I do have my near growth attribute, and I would like the cd from it, from the second input. So at ct equal point, let's say the second input, and I want the cd from the near growth attribute, and I need to get the I. Doesn't work because the semicolon, and now it's well transferred. So this is almost what I want. I want the cust age actually, so let's call it cust age with the f and here cust age as well. Good. Let's check if it works with this visualize. Should be alright actually. Yes, it is. Okay, unfortunately, I mean, for now it's good because I do have 38,000 points, but as soon as I will get 1 billion points there, this operation will be longer. So in order to optimize it, I want to split those two operations, because for the first one it just needs to be computed once. So let's do that. Attribute wangle there on the first frame. So let's get from our control the first frame and freeze it. That's relative reference. This is good, and let's do something like this. I want to get the near point function on the static frame, over the static frame. So this is what I want, and this one on the deformed point over the animation. So let's check it. Okay, see if it works. It's still working. So perfect. Let's optimize it or make it a bit more organized. That's what I want. So now what we can do is to set, let's check with the position. Yes, it works as well, so perfect. We could adjust the noise, and this is what we want to do. So I don't need all of this actually. It's not good anymore. I want something more complex. Not you. Like this. I want to keep the bind because I need to store to get this as a reference from the position, and I will use an anti-alias node like this. With position, I want the 3D noise, 3D vector that I add to the position as well. Not you. Okay, and let's see the results. Okay. Now I would like to multiply this noise by the cust age to make it trigger by the solver. So let's import the cust age with bind up cust age, should be good. So let's see what we do have. Okay, not the good put. So this is the trigger I wanted. Obviously I need to tweak the noise because it's not good for now, and pass relative reference. I could promote those parameters, but it's fine for me inside now. So let's set to, let's say, I don't know, maybe 45 and less amplitude. 0.9, 1. Let's say I want to fit the curve stage. Look like this from 1, not you, 1, not you, 1 to 350. Let's see the result. Yes, something like this. Obviously we are going to add a bit more complexity after, but just for a beginning should be alright. Let's see with the primitive. Seems to be good. Okay. Let's add a bit of more detail, more resolution. Let's say 2. And let's change the background as well. So what is the result? Okay, it seems to be not what we want. Good. So now let's add a bit more complexity with cluster and some good displacement, not over the texture but the geometry directly. So let's do that.